Okay, so these are the characteristics completed, right? And unit of rate constant, last one. The unit of rate constant is depends on the order of the reaction, right? So for first order, second order, zero order, third order. Okay, there was one question was appeared in CET. The unit of rate constant is equals to units of rate of reaction. Then the order of reaction is zero order reaction. Okay, till there completed, right? Okay, next write the continuation. Take one note. Take the note. One. In note 1 write relation between rate constant. Relation between rate constants. Okay, so this is actually we study in chemical equilibrium, but it is related to chemical kinetics also. Let's study here. So relation between the rate constant. So let us take reaction. Take this reaction, N2 gas plus 3H2 gas, okay, gives rise to 2 ammonia gas. Can you tell me, so what is the rate and reaction stoichiometry for this? Rate is equals to minus, tell me, delta N2 by delta T minus 1 by 3 delta H2 by delta T, which is equals to plus 1 by 2 delta ammonia by delta T. Okay, this is we have studied. Okay, now but actually we want this is a rate, right? This rate is equals to what? Rate equal to rate of disappearance of nitrogen. Rate also equal to 1 by 3 into rate of disappearance of hydrogen. Rate also equal to 1 by 2 rate of appearance of ammonia. Okay, now tell me, delta N2 by delta T is what? Rate of disappearance of nitrogen. But I want rate constant. What is the rate? Let us take rate constant of disappearance of nitrogen is K1. I'll take it is a K1. What is a K1? The rate constant of disappearance of N2. And what is the rate constant of disappearance of H2? K2. And rate constant of appearance of ammonia is K3. Then I want relation between K1, K2, K3. It is a 1 which is equals to, it is a 1 by 3 which is also equal to 1 by 2. It means, so K1 equal to 1 by 3, K2 equal to 1 by 2, K3. No, 1 by, So question asked that what is the relation between K1 and K3? So here K1 equal to, it is half K3, then K3 equal to K1. Okay, like that relation between K2 K3, K3 K1 or K1 K2, all the relation can be asked. Okay, bare. Okay, it is a relation between rate constants. Next, second important note is rate law for reversible and continuous reaction. Okay, so rate law for reversible reaction and rate law for continuous reactions. Now tell me, let's say first what is reversible continuous reaction. So reversible reaction in the sense both forward and backward reaction takes place simultaneously. No, the reaction in which both forward and backward takes place simultaneously, that is reversible reaction. For example, let us take AA plus BB which gives rise to CC plus dd. This is a reversible reaction. Printing mistake. Okay, it is reversible reaction. Now tell me, for the reversible reaction, what is the rate? So important, for reversible reaction, the overall rate equal to R1 minus R2, nothing but you can take R forward minus R backward. Let us say it is a forward reaction, then this is backward reaction. For forward reaction, you can take it is a Kf, you can take it is a Kb. So therefore, this is the rate law for reversible reaction. Rate of forward reaction minus rate of backward reaction. Therefore, now tell me, can we write rate of forward reaction equal to what? Take down, don't wait for me. Okay, now tell me, the rate of forward reaction is what? K, okay. Kf no, into A power A, B power B. Then what is Rb equal to? Kb into Allah, for backward reaction, these are the reactant, no? Product converted into reactant. So C power C, C power C, D power D. Come. Then, now what is the rate? The overall net rate equal to, it is a forward minus backward, therefore KFB, Kf into A power A, B power B minus Kb into C power C and D power D. It is for reversible reactions. And if you remember, this is enough, Rf minus Rb. Okay, next is continuous reaction. Tell me, what is the meaning of continuous reactions? The reactions which takes place continuously. Like for example, reactant A converts into B, B converts into C, C converts into D. Like that, so A, B, C. So here A to B is possible, B to C also possible. Continuously A to B converts and B to C also converts. Then now let us take, when A converts into B, it's R1 and rate constant is K1. It is rate constant R2 and R2 rate of reaction, rate constant is K2. Okay. Then for this reaction also, what is rate? Same rate, rate equal to R1 minus R2. That's what we have taken together. The rate law for even reversible reaction, continuous reaction, same, R1 minus R2. Okay, so what is R1, R2, you can get it. Tell me, what is R1 equal to from the above equation? K1 into molar concentrations of A, comma, what is R2 equal to? K2 into molar concentrations of B. Then substitute, then the net rate equal to R2 minus R1, that is K2 into B minus K1 into R1 minus R2. Okay. Next, so this is the rate law for reversible and continuous reaction. Next, third one, rate law for parallel reactions. So what is the rate law for the parallel reaction? So what is the meaning of parallel reaction? Let us take reactant A. The reactant A converts into B and parallelly A also convert into C. That is also possible, right? Here among A and B, so no one is a byproduct. Both are main products only. B is a main product, even C also main product. So therefore, in such reactions, they are called parallel reaction. For parallel reaction, A converts into B. Its rate is R1, its rate constant K1, and A converts into C, rate is R2, constant is K2. Then what is the rate law for parallel reaction? Their rate is equals to R1 plus R2. So remember, it is addition for a parallel reaction. Okay. So can you write what is R1, R2? Tell me. Where R1 equal to K into molar concentration of A, comma R2 equal to K2 into molar concentration of A only, because for the both the reaction A is the concentrate reactant. No, A is the concentration reactant. Next, then rate equal to R1 plus R2, K1 into A plus K2 into B, K2 into A. Then so here A is common, so therefore you can write A equal, rate equal to A into okay. Okay. Next is reaction mechanism. So what is reaction mechanism? And based on reaction mechanism, reactions are classified into two types. Okay. Now let's see first what is reaction mechanism. Tell me, what is the reaction mechanism? We study in organic chemistry, right? There is a first step, second step, third step, right? So usually organic reaction takes place in a stepwise, in one step, second step, third step, then overall it converts into product. So many reaction takes place in a stepwise. When the reaction takes place more than one step, then it is necessary to write mechanism. Okay. Then what is the meaning of mechanism? So the meaning of mechanism is the detailed step by step explanation of a chemical reaction. Yes or no? The detailed step by step explanation of a chemical reaction. For example, you can take A. A is a reactant, convert into D is a product. Okay, reactant A convert into product D. Now this is actually reaction, but what is the mechanism? Its mechanism is a detailed step by step explanation. It means step 1, what happened? In step 1, which reaction takes place? In step 3, which reaction takes place? Then by combining all the steps, you will get overall reaction. Now tell me, for example, step 1. In step 1, A converts into B. In step 2, B converts into C. In step 3, C converts into D. Okay, then what is the overall reaction? The overall reaction is C cancelled, B cancelled, then A become D. This is overall reaction. But the step by step explanation of this chemical reaction is called what? Mechanism. Now this is a mechanism of this particular reaction. It means mechanism is nothing but the detailed step by step explanation of a chemical reaction is called a reaction mechanism. Alright. Now based on reaction mechanism, reactions are usually classified into two types. One, simple reactions, they are also called elementary reactions. Simple reaction, and they are called elementary reactions. This word very commonly used, elementary reactions. And second one is complex reactions. Tell me, there is no other name. Complex reaction. So therefore, based on reaction mechanism, reactions are classified into two types, simple reaction and complex reaction. They are also called elementary reaction, simple. Then tell me, what may be the simple reaction? The reaction which takes place in a single step, right? The reaction which takes place in a single step, such reactions are called what? Simple reactions. Like for example, A converts into B directly, right? If A converts into B, there is no any intermediate, there is no any other reaction. This reaction takes place in single step. It is a simple reaction. Therefore, all the simple reaction takes place in a single step. Therefore, if the reaction takes place single step, that step itself is called a elementary step or elementary reaction. If reaction takes place in a single step, the single step itself is called elementary step or elementary reaction. Okay. So therefore, next is complex reaction. So what are complex reaction? The reaction which takes place more than one step, right? See, the reaction which takes place more than one step, it may be 2, 3, 4. Such reactions are what called? Complex reaction. But the important of complex reaction is, if the reaction takes place more than one step, the only one step is a slow step. Remaining all the steps are what? Fast steps. So only one step is a slow step, remaining steps are fast step, and the reaction which takes place slow step, no, that is called rate determining step, RDS, rate determining step. For example, you see here, if the reaction takes place A, B, no, step 1, step 2, step 3. Okay, in 3 steps, there will be only one step is a slow step, comparatively. Now let me take, this is a slow step, it is a slow step, okay, it is a fast step, this is a fast step comparatively. There is no any other measurement. Slow irbekandre, stay irbekandre. Comparatively, these two, this is a slow step. Therefore, if the reaction A converts into B is a slow step, which is called what? Rate determining step. Therefore, in this reaction, this is a RDS, rate determining step. That means the rate of the chemical reaction depends on only this step, A to B. Rate is independent of B to C, C to D. That is the important of what? Rate determining step, that is a slow step. Okay. So we have some examples. Now let's say, example for simple reaction, you have taken A to B. Now you can take example, decomposition of PCl5, right? When PCl5 undergo decomposition, PCl5 undergo decomposition, which gives us PCl5 and gas. It gives rise to PCl3 gas plus Cl2 gas. Now this reaction takes place in a single step. It completes in a single step. Therefore, this step itself is called what? Elementary step, and it is also RDS, rate determining step. It means if the reaction takes place in a single step, that single step itself is called RDS, rate determining step, which is also called elementary step. Okay, this is very simple. But for us, where we get confusion is about complex reactions. Okay, so complex reaction is the reaction which takes place more than one step. Okay, the reaction which completes more than one step, such reactions are complex reaction. If the reaction completes more than one step, only one step is a rate determining step, that is a slow step. Other reactions are fast step. Those fast steps does not alter the rate of the reaction. Only slow step alter the rate of chemical reaction. Okay, all right, these things are we have studied. But example is what? So example is decomposition of N2O5. The same example given in textbook, NCR textbook, decomposition of N2O5. Okay. Now, say when N2O5 undergo decomposition, this is the reaction. 2N2O5 gives rise to 4NO plus O2. It is balanced. Okay, if I write this equation, it looks a single step. This reaction taking place single step. But actually, this reaction doesn't take place single step. It takes place in 2 steps. Therefore, what is the step 1? In step 1, there are 2 N2O5. 1 N2O5 undergo decomposition. It gives rise to NO2 plus remaining is NO3. NO2 plus NO3, N2O5. Now this step is a slow step. Okay, next there is another N2O5, because there are 2 N2O5. Another N2O5 reacts with NO3. Okay, which gives rise to total 4 NO. No? Only NO is there. 3 N. NO. Tell me. 3. No, is it NO is right? 4. Okay. 3. Ah, 4 NO plus. No. Say, let me clear first this. 2 2s are 4. 4. 2 5s are 10. No. It is actually NO2 only. So that 8 10. It is NO2 correct only. Then 3, yeah, correct only. Okay. This is 3 NO2 correct only and O2. This is right. NO2 plus O2 correct. Okay. Now it is balanced. So therefore, now tell me this is a fast step. Right. Okay. It means it is a step 2. Now question is, okay, decomposition of N2O5 undergo decomposition, it gives NO2 plus O2. This reaction takes place in 2 steps. When the reaction takes place more than one step is a slow step comparatively. This is a comparatively slow step which is called rate determining step. Okay, then what is the importance of this rate determining step? The importance of rate determining step is the rate of the chemical reaction depends on only this step. It means if you want to apply the rate law can be applied for only what? RDS. That means, so according to rate law, tell me what is the rate equal to for this reaction? K into molar concentrations of N2O5 power 1. It means, so you should apply the rate law for only this equation, not this equation. This is called rate law, and moreover this is called experimentally determined rate equation. This equation is called rate equation, that is experimentally determined rate equation. So therefore, now here onwards, wherever we apply the rate law can be applied to either elementary step or RDS, not all the steps. Then only you get this is experimentally determined rate equation. Okay, so it is about a complex reaction. Okay, right. Right on. Reaction mechanism. Right. The detailed step by step explanation of a chemical reaction is called the detailed step by step explanation of a chemical reaction is called reaction mechanism. Is called reaction mechanism. Next, right, based on reaction mechanism, reactions are classified into based on reaction mechanism, reactions are classified into 2 types. Based on reaction mechanism, reactions are classified into 2 types. One, simple reactions or elementary reaction. Simple reaction or elementary reaction. 2, complex reaction. Okay, right, simple reaction. The reaction which completes in a single step. The reaction which completes in a single step called simple reaction or elementary reaction. Take this A to B. So can apply the now A to B single step now. Since it is a single step, which is RDS, this this step itself is a RDS. Okay, therefore for all elementary reaction, so the single step itself is a RDS. Now tell me, what is the rate equal to? K into A power 1, nothing but 1, no. So take this simple reaction and take example decomposition of PCl5, that is elementary step. Next, complex reaction. Complex reaction. The reaction which completes two or more step called complex reaction. Next point, if the reaction completes more than one step, next point, if the reaction completes more than one step, only one step is a slow step, which is called rate determining step. That is, rate is independent of fast step. Next point, if the reaction completes in a single step, it is called elementary step. And itself is a what? Rate determining step. So take this general example. A gives rise to D, its reaction, but which takes place in 3 steps, 1, 2, 3. Okay, take the 3 steps and apply the rate law. So tell me, according to rate law, what is the rate? Come on, tell me. Rate equal to what? Rajeshwari. Rate equal to, okay, take this is a K1 rate constant, it is a K2 rate constant, K3 rate constant. Because every step has rate constant, no? Tell me, rate equal to K1 or K2 or K3? K1 into molar concentration of A power 1. That's it. Can you apply the rate law for these two? No. Rate law is applicable for only RDS or elementary step. Okay. So take general example, then take this decomposition of N2O5. Hmm? Finished? Next is molecularity and order. Which one, tell me? It is experimentally determined rate equation. ಕೇಳುವಾಗ ಕರೆಕ್ಟ್ ಕೇಳಬೇಕು, ಬರೆಯುವಾಗ ಹಂಗಿರುತ್ತೆ. Okay, next is molecularity and order. So what is molecularity? Types of molecularity. And what is order? Types of order of reactions. Okay, let's say molecularity. Let us take reaction is A plus B. Okay, it gives rise to product something. Product is formed. Okay, what is molecularity and how to identify the molecularity and importance of molecularity in chemical kinetics? See, molecularity, the simple definition of molecularity is, before molecularity you must know, in morning classes we discussed, usually reactant A and B converts into product. When this is possible? When reactant A and B, they must collide with each other. They must in contact with each other, they must collide with each other, right? So if the reactant A and B collide with each other, they form product. But is it all collision makes fruitful product? No. So that is again different. So all the collisions does not give the product. Therefore, which collision gives the product? The collision between the active molecules, that is activated molecules, right? The molecule which are having energy greater than threshold energy. If any molecule having energy greater than threshold energy, those reactant molecule convert into what? Product. That, right? The molecule which are having energy greater than threshold energy, those molecules are called what? Activated molecule. That means finally the collision between the activated molecules can only form the product. Okay, that's the statement. Now tell me, what is the molecularity? So molecularity says exactly that only. Molecularity is, it is the number of reactant molecule which take part in the rate determining step or elementary step. The number of reactant molecule take part in the RDS or elementary step, and they make collision with each other to form the product. That is called what? Molecularity. Therefore, in molecularity 2 points are important. The number of molecule which take part means they should be involved in the RDS. Again, molecularity also be calculated at RDS or elementary step, and they must collide with each other, because in order to get product, collision is required. They must collide with each other to form the product. That is called molecularity. Then molecularity always, it is a whole number, it never be fraction, right? So molecularity always whole number, it never fraction, and molecularity is never zero. it never becomes 0. So suppose if I say molecularity is 0, what is the meaning of that? There is no reactant, isn't it? There is no reactant means there is no product, means no chemical reaction. Then why you study? ಏನಿದೆ ಸ್ಟಡಿ ಮಾಡೋಕ್ಕೆ ಅಲ್ಲಿ ಅಷ್ಟೇ ತಾನೇ. ಸೊ ದಟ್ ಮೀನ್ಸ್ molecularity 0 is not possible. There must be at least one molecule, no? That's what molecularity always whole number, it never fraction. If I say fraction, suppose if I say molecularity is 1/2, that is 1/2 half or 2/3, what is the meaning of that? Molecularity 1/2 ಅಂದರೆ half molecule ಇರುತ್ತಾ? ಹಂಗೇನಾರು ಓದಿದ್ರೆ ನೀವು? ಹಾಫ್ ಆಟಮ್ ಹಾಫ್ ಮಾಲಿಕ್ಯೂಲ್ ಥರ ಕಾನ್ಸೆಪ್ಟ್ ಓದಿಲ್ಲ ತಾನೆ? ಹಾಫ್ ಆಟಮ್ ಇದ್ದರೆ ವಾಟ್ ಅಬೌಟ್ ಎಲೆಕ್ಟ್ರಾನ್, ವಾಟ್ ಅಬೌಟ್ ಪ್ರೋಟಾನ್, ಇನ್ನೊಂದು ಹಾಫ್ ಪ್ರೋಟಾನ್ ಎಲ್ಲೋ ಬೇಕು? ದಟ್ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ಡೋಂಟ್ ಸ್ಟಡಿ. ಕೆಮಿಸ್ಟ್ರಿ ಅಂತಿಲ್ಲ, ಫಿಸಿಕ್ಸಲ್ಲಿ ಗೊತ್ತಿಲ್ಲ ನನಗೆ ಅದೇ. ದಟ್ ಮೀನ್ಸ್ ಮಾಲಿಕ್ಯುಲಾರಿಟಿ ಹಾಫ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್, ಫ್ರಾಕ್ಷನ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ಸೊ ದೇರ್ ಫಾರ್ ಮಾಲಿಕ್ಯುಲಾರಿಟಿ ಈಸ್ ಆಲ್ವೇಸ್ ಹೋಲ್ ನಂಬರ್, ಇಟ್ ನೆವರ್ 0. ನೆಕ್ಸ್ಟ್ ಈಸ್ ಮಾಲಿಕ್ಯುಲಾರಿಟಿ ವೆದರ್ ಇಟ್ ಈಸ್ ಎ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ವ್ಯಾಲ್ಯೂ ಆರ್ ಥಿಯರಿಟಿಕಲ್ ವ್ಯಾಲ್ಯೂ. This is a theoretical value, not experimental value. Order is experimental value. Molecularity can be written by seeing the equation. For example, if I write A plus B gives rise to C, then what is the molecularity? 1 plus 1 equal to 2. Can you say order is 2? No. It means order is purely experimentally determined value, that is. But this is a theoretical value. Since molecularity is a theoretical value, it does not depend on reaction condition. Temperature change ಆಯ್ತು ಅನ್ಕೊಳ್ಳಿ, temperature T1 and temperature become T2. What is the molecularity? Same. If you increase the temperature, 2 molecule become 4 molecule. ಆಗಲ್ಲ ತಾನೆ? 2 molecule never become 1 molecule. That means it doesn't depend on what? Reaction condition. Then quite opposite is order. Okay? So therefore, first is what? Definition of molecularity. What is the definition of molecularity? The number of reactant molecule which take part in the chemical reaction and they must collide with each other to form the product, called molecularity. Molecularity never become whole, it is a whole number, it never becomes 0, and it is a theoretical value, and does not depends on reaction condition. Not depends on reaction condition. Next, if the molecularity 1, 2, 3, 4, it is called what? Unimolecular reaction. Molecularity 2 bimolecular, molecularity 3 trimolecular. ಅಷ್ಟೇ ಸಾಕು. So therefore unimolecular, bimolecular, trimolecular, molecularity 1, molecularity 2, molecularity 3. Then next is we don't have fraction molecular, we don't have fraction, what is 0 order is there, 0 molecularity is not there. Okay. Then next here we have example. Unimolecular reaction, definition example. Bimolecular reaction, definition example. Here only examples should be remembered. Tell me, we'll finish here only. Unimolecular reaction. So what is the unimolecular reaction? The reaction in which only one the reaction which involved only one reactant molecule involved in RDS. The reaction in which only one reactant molecule involved in RDS and there is a collision takes place between the one molecule. Okay, that is a unimolecular. Bimolecular, the collision takes place between 2 molecules. Trimolecular, 3 molecules. Like that 4 molecular, molecularity 4. But we have example for uni, bi, tri. So can you tell me example for unimolecular reaction? The same example 1. Decomposition of PCl5. PCl5 gives rise to PCl3 plus Cl2. This is unimolecular reaction. Okay. Next is bimolecular reaction. The reaction which involves the simultaneous collision between the 2 reactant molecule. So 2 reactant molecule simultaneous collision, you can take N2 plus O2 gives rise to 2NO. Okay, it is a bimolecular. Even you can take H2 plus I2, 2HI, it is also bimolecular, where 2 reactants involved and there is a simultaneous collision takes place between 2 reactant molecule. Next is Trimolecular. The reaction in which simultaneous collision takes place between three reactant molecule, that is NO plus O2. It is NO2 okay, trimolecular, and even 2SO2 plus O2 to SO3, it is also trimolecular. It is about molecularity. Okay, about order quite opposite to this one, and order is something different and more important. Right on. Molecularity. The number of reacting species, the number of reacting species of reactant, the number of reacting species of the reactant taking part of elementary reaction, taking part in elementary reaction or RDS, taking part elementary reaction or RDS, in order to bring the chemical reaction, they must collide with each other simultaneously. They must collide with each other simultaneously, called molecularity. Right? Next, right. It is, next point, it is always whole number. It is always whole number, comma, it never becomes zero. It never become zero. Next, if molecularity 1, 2, 3 called, if molecularity is 1, 2, 3 called, what are they called? Unimolecular, bimolecular, trimolecular respectively. Unimolecular, bimolecular, trimolecular respectively. Right, next, right, unimolecular reaction. Unimolecular reaction. The reaction which involved unimolecular reaction. The reaction which involved simultaneous collision between the reaction which involve simultaneous collision between the one reacting species called unimolecular reaction, Example, PCl5 gives rise to, you can take this and you can take even ammonium nitrite, NH4 twice. It gives rise to N2 gas plus 2H2O. Okay, so what is the molecularity? 1, right? Next, bimolecular, same definition, right? The reaction in which there is a simultaneous collision between how many molecule? 3 reacting molecule. The reaction which involve simultaneous collision between 2 reacting species or 2 reactant molecules. So trimolecular definition, right? Same definition. Right, example. Finished? So it is a order. It is molecularity. Next, right? Order. Right, what is order? Tell me. So what is the definition of order? Say, let us take a reaction XA plus YB gives rise to something product. Right. So consider reaction. It is, and tell me what is the rate law. So according to rate law, rate equal to okay, K into rate constant K into A power X B power Y. Now this is called experimentally determined rate equation, not simple rate equation. It is experimentally determined, means experimentally proved one. So this is a rate equation. Right, experimentally determined rate equation. Okay. Now tell me, what is the order? What is order? Huh? It is the sum of the powers of the molar concentrations of reactant in experimentally determined rate equation. Right, see, sum SUM, not SYME. Sum of the powers of the concentrations of reactant in experimentally determined rate equation is called order. Okay. So therefore, now tell me, according to the statement, what is the order? So order equal to, it is the X plus Y. Okay. This is order. Or, so another definition. Okay. So another definition is order also be defined as when reactant converts into product. Okay, let us take it is RDS or elementary step, right? The number of reactant molecules changing their concentration in RDS. The number of reactant molecule changing their concentration. See, difference is, what is the molecularity? Molecularity says that there are how many number of molecule in RDS. Aste. The number of reactant molecule present in RDS is order. Sorry, molecularity. But order is, it is, yes, no, presence, let it be 1, 2, 3, whatever it is. But order says that how many reactant molecule changing their concentration. Right. If two reactant molecule changing their concentration RDS, then order is 2. If only one reactant molecule changing their concentration, order is 1. Therefore, that is the difference between order and molecularity. Therefore, the number of molecule present in RDS is molecularity. The number of reactant molecule changing their concentration is order. In simple term, order also defined like this. It is the sum of the powers of the concentrations of the reactant in experimentally determined rate equation. Okay, now question is like this. It is A plus B gives rise to C. Okay, small a, small b will be there. Gives rise to C. What is the order of reaction? Small a plus small b. Are you sure? It means ನಿಮಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತ. What is the molecularity? Molecularity A plus B, all right. What is the order? Order cannot be determined theoretically. By seeing equation, you cannot say that order A plus B. Order is what? Experimental value. Order may be A, order may be B, even order may be 0 also. Artha agilla. Then what is the use of this writing? Aitane, next question. So it means if somebody write equation, then if they ask, you know, what is the order, you cannot say that order something. So order cannot be predicted by seeing equation, but order can be predicted by rate equation. What is the rate equation? If I write rate equation for this, rate equal to k into a power a b power b ಈ ಥರ ಬರೆದ್ರೆ ಅವಾಗ ಹೇಳ್ಬೋದು ನಾವು a plus b is a order. This is all right. Unless somebody write this, you cannot identify the order. That's important. So to identify the order, equation is not enough. Or else, if they give equation, they must give it is RDS. If they give RDS, you can write this. If you write this, you can identify AB. That is order. Adunu possibility there. But I have not written anything. I am asking that order. That means order cannot be predicted unless you know rate equation. This rate equation is what? This is experimentally determined. ನಾನು ಈ ಥರ ಬರೆದಿರೋದು ಅದರ ಅರ್ಥ ಏನು? ಇದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲಿ ಪ್ರೂವ್ ಆಗಿದೆ ಅಂತ ಆದರೆ ಬರಬೇಕಷ್ಟೇ ಈ ಥರ. ಬಿಕಾಸ್ ರೇಟ್ ತಾನೇ, ರೇಟ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಎ ಆ್ಯಂಡ್ ಬಿ. It means when this is possible, when somebody proved experimentally, right? Therefore, this equation is called experimentally determined rate equation. Therefore, order can be identified from the experimental determined equation, but not this equation. Okay, ಭಾಳ ಸಿಂಪಲ್ ಆಗಿ ಕೊಟ್ಬಿಡ್ತಾರೆ a plus b ಏನಾಗುತ್ತೆ ಅಂದರೆ ನೀವು ವಿತೌಟ್ ಎನಿ no time you tell that it is a plus b, not. Okay, then that is order. Next, order may be whole number, maybe it may be fraction, right? So order may be whole number, it may be fraction, even it is 0 also. Okay, suppose if I say order is 0, what is the meaning of that? Tell me. Order is 0 in the sense in RDS, rate determining step, no reactant is changing their concentration. ಅಷ್ಟೇ ತಾನೇ? There are reactant are there, but no reactant changing concentration, right? It means no reactant changing concentration means rate is independent of this concentration, no? Yes or no? That means rate is independent of concentration. For example, A plus BB gives us to C. I say that this A is A. With respect to A, rate is 0. It means A power 0. You don't see that A is there. Why A power 0? At RDS, this A is not changing their concentration. If it is not changing its concentration, means no involvement of reactant, no. A is not involving in the chemical reaction. If it is not involving in the chemical reaction, order with respect to that is 0. So all are interlinked. Therefore, now then we write like this is the equation. It is experimental equation. That's what, if even at experimentally determined that B also not changing concentration, A is not changing, B also not changing. If B is not changing, B power also 0. Then tell me what is the overall order? 0. That means order may be 0, order may be fraction, it may be even. Yes, even order may be negative also. Yes or no? Order is negative, particularly ozonolysis. This was a 2019 I think question paper, they asked given ozone order. It comes negative. So order may be even negative, even positive. And next, order depends on experimental condition. Yes or no? As the temperature increases, it changes. As pressure increases, changes. Right? So therefore, as the experimental condition changes, then order changes. And it is experimentally determined. Molecularity is theoretically calculated. Okay? Then we have types of order of reaction. So you got clarity here? Write down order. Write first definition. Write the definition of order. The sum of the powers of the concentrations of reactant, the sum of the powers of the concentrations of reactant in experimentally determined rate equation. In experimentally determined rate equation called order of reaction, over R. Another definition, or the number of reacting species changing their concentration, in rate determining step, also called order. Okay, right on. Consider a reaction XA plus YB gives rise to product. Consider a reaction XA plus YB gives rise to product. Then write rate equal to K into A power X B power Y. Okay, that is rate equation. Then order equal to X plus Y. Order equal to X plus Y. Next, right. Next, right. Order may be whole number. Or fraction. Even it is 0. Next, order may be negative or positive. Next, order is experimental value. It depends on reaction conditions. It depends on reaction condition. Okay. Example. A plus 2B gives rise to 3C. Take equation. A plus 2B gives rise to 3C. What is the order of reaction? Order cannot be calculated, no? Yes, order may be, order may be first, second, 0. It cannot be calculated first of all. Then what is the molecularity? Molecularity can be calculated. It is 3. All right. Molecularity is 3. Okay. Suppose if I write the rate equation, rate is equals to K into A power 1 B power 2. Tell me now what is the order? If I write this equation, then you can say it is a 1 plus 2 equal to 3. Okay. Next, one example. Ammonia gas plus water, it is excess, gives rise to ammonium hydroxide. It is a aqueous medium. Tell me what is the order of this reaction? Huh? 1 or 2? Why? It means you need to write first rate law. According to rate law, rate is equals to what? K into molar concentrations of ammonia power 1 and molar concentration of water 0. Why? In a chemical reaction, if any reactant taken large quantity or excess quantity, with respect to that reactant, order is 0. Means this rate, this concentration does not affect the rate. Whether you take large or more, whatever it is. So whether present or absent, its concentration doesn't matter. Therefore, now order equal to what? Order is 1. One more example. Decomposition of N2O5. Okay, so decomposition of N2O5, we have written equation. So here 2N2O5 gives rise to 4NO2 plus O2. But what is the step 1? 1N2O5 decomposes to form NO2 plus NO3. This is a RDS. Why this is RDS? Slow step. Who told it is slow step? Experimentally determined. Yaar helilla. It is experimental value, no? Okay. Next is step 2. There is another N2O5 which is also reacts with NO3. It forms 3NO2 plus O2. This is the fast step. Fast step you need not write. Slow step bardu saku. Ulindalla fast antane artha. Okay. Now tell me, write the rate equation. Whether rate law applicable for first or second equation, second step. So rate law applicable for only RDS. Therefore, according to rate law, rate is equals to K into N2O5. I'll take this is a K1, it is a K2. K1 into N2O5 power 1. Therefore, what is the order of reaction? Okay. But if you see this equation, you may feel it is a order is 2 because 2 is there. But what is the molecularity? Molecularity equal to 2, of course. You don't understand? Wait. We'll study about molecularity later. Hear? No. the number of reactant molecule which involved RDS. Suppose if it is a RDS ಅಲ್ಲಿ 2 reactant ಇದೆ, molecularity 2 ಬರುತ್ತೆ. ಓಕೆ, molecularity 2 ಬರುತ್ತೆ, ಬಟ್ ಆರ್ಡರ್ 1 ಬಿಕಾಸ್ ಎಕ್ಸೆಸ್ ತಾನೆ. ಡ್ಯೂ ಟು ಎಕ್ಸೆಸ್ ಕ್ವಾಂಟಿಟಿ there is no change in concentration of water. Of course, molecularity 2. Okay, fine. Next is types of order of reaction. Right on. So what are the types of order of reaction? Come on, tell me. 1. Types of order of reaction. 1. Zero order. Take down. Zero order reaction. 2. First order. 3. Second order. 4. Third order. 5. Fraction order. Okay. 6. Pseudo. Pseudo first order reaction. Okay, we'll continue next class.